Okay, all of you pay attention. Very first question I am starting with cos of cos x. You focus on this one, that cos x will lie between -1 and 1. Now this -1 to 1 is broken further into -1 to 0, 0 to 1. On the number line you can see this -1 to 1, there is an intermediate number, that is 0. So because of that it is written -1 to 0 and 0 to 1. Then I have taken the throughout cos, that is cos is added throughout in this one and cos is added throughout in this one. Now this -1 or this 1, when we have added cos, it will be treated as in radians. The value of pi radian is 3.14, and 3.14 when divided by 2 gives you minus 1.57, and over here plus 1.57. Now 1.57, before that you have this 1, and minus 1.57, before that you have minus. Alright, this minus, I have explained you, -1 will be falling in before this minus 1.57 and this 1 will be before 1.57. So -1 and 1 are reflected over here. Then you see over here I have drawn the graph for cosine function. Earlier I have shown you the graph for the sine function. The graph for cosine function will be like this. As you know from the 10th class trigonometry, that cos 0 is equal to 1, alright, and cos pi by 2, that is cos 90, is equal to 0. Cos minus pi by 2 or cos minus 90 also will be equal to 0. Now as it was written as minus 1.57, so -1 is taken over here and 1 is taken over here. You can see there is a highlighted area, this one. Alright, so this highlighted area for cosine function, cos function, is from -1 to 0, which is shown over here. Now there is a catch over here. When we have written cos in front of this -1 throughout, then you find that when we are moving on the x-axis towards this 0, you can see all the values of cosine function for those angles, they keep on increasing. Alright, keep on increasing. So because of that, this sign of inequality will not change over here and here. And cos of minus theta, already I have explained you, is equal to cos theta. So cos -1 will become cos 1 and cos 0 is equal to 1. So this one is the maximum value and this one is the minimum value. Same result you have to get for this one. But there is a catch over here. You can see when 0 is taken, the sign of inequality has changed over here. The reason being, as you are moving towards this 1, that is angle is increasing, then you see the length of perpendicular keeps on decreasing. Length of perpendicular keeps on decreasing, and as the angle is increasing, so the cosine function cos theta of that for that particular angle will keep on reducing. So because of that, this sign of inequality has changed into this one. I hope the point is clear to all of you. So when we have written cos in front of this, then cos 0 is equal to 1 and cos 1 remains as it is. So in this one as well as in this one, both we are getting the same result, that is the maximum value of cos x is equal to 1 and minimum value of cos x is cos 1. Same thing is over here. That is why the answer is 1 and cos 1. This one is the maximum value and this one is the minimum value. I hope the point is clear to all of you. Now coming to coming to this sine of sin x. Sine of sin x, first of all I have drawn this graph for the sine function as was explained in the previous problem. Alright, at pi by 2 you are finding that it is equal to 1. At minus pi by 2 it is equal to minus 1. Now your sine x, again I have written it like this. Sine x is between minus 1 to 1, and that one is not broken in minus 1 to 0 and 0 to 1, because you can see we have to do all our activities between minus 1 to 1 itself, because if you put sine in front of this whole thing, then you are getting sine of minus 1 and this sine 1. This sine of minus 1 will become minus sine 1 and sine 1 remains as it is. This minus 1 and 1 are shown over here. This is the minus 1 on the x-axis and this one is the 1. As I have already explained you that pi by 2 is 1.57 and minus pi by 2 is minus 1.57. So minus 1 will be ahead of this minus 1.57 and 1 will be ahead of this 1.57. So here you see when you are moving towards the 0, then you find that as the angle is increasing, this side we are angle is increasing, so the value of sine theta also keep on increasing. You must be wondering, this one is below the x-axis. So as we are moving towards this, then the length of perpendicular keep on reducing, but there will be minus sign in front of them. So as we are moving towards the 0, the sign of the angle keeps on increasing. Same thing is happening over here. So because of that, this minus 1 and 1 was not broken in as it was done in the. Okay, for the last one, sine of cosx, you see cosx is written as minus 1 to 1, which is again further broken like this. I think it is not needed to break it in this manner. We can directly write sine in front of this and sine in front of this, so that we are getting sine of minus 1. I have not shown over here. Sine of minus 1 is minus sine 1 and this one is sine 1. So this is what we are getting over here. In this one also we can see this sine 0 is 0. That is an intermediate value of sine of cosx in between this and this, between this and this, and this and this. So out of that, this 0 is the intermediate value. We need not to do it like this. As already I have explained you, just put sine in front of this, sine in front of this, sine, so that sine of minus 1 will become minus sine 1 and sine 1 remains as it is. So this will be the minimum value and this will be the maximum value. I hope the point is clear to all of you. Slight confusion, maybe slight confusion will be there just because of this thing, but you can ignore it. You can directly take sine minus 1 over here, then sine of cos x over here, and this sine of 1 over here. Remove this part and this part, means ignore this sine 0 you ignore. So finally we are getting minus sine 1 and maximum value is sine 1. I hope the point is clear to all of you. Thank you.